Okay, question 9. A box of 3 kilograms lies on a rough inclined plane, angle at 40 degrees to the horizontal. The box is held in equilibrium by means of horizontal force, magnitude x newtons. The line of action of the force is the same in the same vertical plane as the greatest slope. Blah blah blah. The coefficient of friction is 0.3. So I'm going to redraw this because I don't like a pushing force. So there's nothing wrong with me drawing that with 3 kilograms, and instead of putting a pushing force I'm going to do a pulling force like that, and that is x newtons. We're also told that mu is equal to 0.3. Okay, we've got its weight component acting down like that, which will be 3g. We've got the normal reaction from the surface. The surface will be like that, pushing out like that, right angles. That's why it's called normal. That's R, and it says it's in limiting equilibrium and is about to move up the plane, which on the verge. Right, if you're at limiting equilibrium, you are at F max. So that's going to be oppose the motion wanting to go up the plane. So that is called F max for sure, because we are in limiting equilibrium, just on the point of moving. Okay, so find the normal direction between, so we've got to find R and the box of the plane and find X. So what we've got is componentalize these two forces. So if I just do wrong thing, click onto that, componentalize this force. I've got one going in that direction and a component going in that direction. The component going in, change colour, this direction, well, if that's 40 degrees, that's a corresponding angle, so that's 40 degrees there. So that means the force X times by its component, which is going to be cos 40, and the component going down here is the force X times by its component is sin 40. Now in a similar vein, going to componentalize this force here, the weight, with a bit going down like that and a bit going down like that. Okay, so, and again, whatever the inclination is here, you'll get the same angle just here, that's 40 degrees. So the bit going down here is the force 3g times by its component, which is cos 40, and the bit going down here is the force 3g. In fact, I'll rub that, give myself some space, 3g, and times by its component, which is going to be sin 40. Okay, so if I resolve in the vertical sense, sorry, the perpendicular sense, so resolve, in fact change colour, resolve in the perpendicular sense in that way is positive, brackets, using Newton's second law, net forces equals mass times acceleration. It's not accelerating out, it's not sinking in, the sum of the forces is equal to 0. So the only positive force I've got is R, and the two opposing forces are the X sin 40 and the weight component, which is the 3g, and it is sin 40. And we know the sum of those forces is equal to 0. Okay, so straight off we can see that R is equal to, throw it over there, and that will help us find that there. So I'm going to write down R is clearly equal to X sin 40 plus 3g sin 40, and we'll come back to that in a bit, so I'll highlight that. Okay, alright, so there's the first little bit. Right, next thing is to resolve up the plane. We'll say is positive, so parallel to the plane. Normal, net forces equals ma. Well, it's not accelerating anywhere, so it is 0. So this is Newton's second law, law of motion. We've got the only positive force is the X cos 40, and the two opposing forces is your 3g, so minus 3g sin 40, and the opposing force is F max, and we know that that is equal to 0. Now I know that f max, if I come back over here, f max is simply equal to 0.3, which was mu, 0.3 times this here. So 0.3 lots of x sin 40, I think I've missed a 0 just there, sin 40 plus 3g sin 40, okay. X sin 40, that's right, and that's not sin 40, it's 3g cos 40. Okay, my bad, that's cos 40 just there. Okay, and that makes that cos 40 just there. You might mess with this, and that's cos 40 just there. I don't know why I just did that. That's resolving in this sense. I think I must write that down, I don't know why. Okay, so that's all correct now. That's what I've got there. That f max is going to go replacing that. So I end up with x cos 40 minus 3g, and it is sin 40 minus f max. Well, that happens to be all of this gumph, which is 0.3 brackets x sin 40 plus 3g cos 40. And we know all of that equals 0. So coming up here, I've got x first of all. I can work out. Once I've got x, I can shove it back into there to find r. So it's telling you to find x second, which is weird. It doesn't matter. The easiest, the obvious way is to find x first of all. So I'm going to expand this out, keep together the x's, and throw everything else on the one side. So I've got x cos 40. That times that contains an x, so it's minus 0.3 x sin 40 equals, that is going to be thrown over to give you 3g sin 40, and that times that is going to be negative. Once it gets thrown over, it gets positive, and 3 lots of 0.3 is 0.9 lots of g cos 40. Factorize this by pulling an x out and then dividing through by it. You end up with x is equal to whatever the result of 3g sin 40 is plus 0.9g cos 40, and it is all divided by this factorized, which is going to be cos 40 minus 0.3, and it is sin 40, and again missed a 0 off there. That's weird. I made quite a few weird silly mistakes. Anyway, we've got x is equal to calculator out, and then using the fraction button, brackets on the top there, it is 3 times 9.8 times by sin 40 close brackets plus open brackets 0.9 times 9.8 times by cos 40 close brackets, go down, divide by cos of 40 close brackets minus brackets 0.3 times by sin 40 close brackets equals, and we get 44.8. So 44.8 newtons. That's our answer to B. And our answer to A is getting this unrounded answer up and shoving it back into here, just here. Okay, so therefore for part A we end up with R is equal to our unrounded 44 point, I think it said 7, didn't it? 7. Okay, so 7 times by sin 40 plus 3g cos 40. So that is going to give us an R of, so we've got my previous answer, previous answer, which I've got stored there, and I'm going to times that by, in fact, brackets answer times by sin 40 close brackets, plus close brackets open brackets times by 9.8 times by cos 40, close and close, and equals, and we get R is 51.3 newtons. Okay, so that's what I make it, and we'll just